Hi everyone. Welcome in another session of AI/ML. The last session we have completed everything like the theoretical part, the explanations, everything we have completed related to neural network. So today we will be going down and seeing how to just train the model using the neural network. Okay. Let's just go into it. So I'll just take the share the screen and then we'll go ahead. Okay. Yeah. So hopefully my screen is visible to you people. So we'll directly go down to this code. Okay. So basically we will be first taking single layer perceptron for Irish classification. So we are taking the data set here, the Irish data set, because this is the simple one. So you'll be able to understand it. So once you are able to figure out how simple things work, you'll be able to work with any type of data set or any type of codes in that format. Okay. So basically here what we are doing, so we are building a single layer perceptron, okay? It learns to classify the flowers, okay? Which learns to classify what flowers it would be. So it will basically answer us the question, which type of Irish flower is it? As you all know, so there are three flower types in Irish dataset, that is Setosa, Versicola, and Virginica, right? So it will be taking like that. So first we will be importing the data set. So we have import NumPy as NP. So NumPy help us to work with numbers and arrays. We actually rename it as NP to save the typing and the part. The thing is like NumPy as a math or like a as a part that actually helps us to take it forward with the mathematical aspect of it. Okay. Now here for perceptrons or neural network, we will be using TensorFlow. Okay, so TensorFlow is a deep learning library. It helps us to build a like neural network. For that, for any of the neural network, basically we will be using TensorFlow and Keras as well. Okay. Now coming down, we have from TensorFlow.keras.models import sequential. Okay, sequential means layers are added one after another. Okay, because as you know, in case of neural network, we have different layers. We have different layers that are taken forward. So we need to take it like that. Okay. Now, if you can see, we have from TensorFlow Keras dot layers import dense. This is the fully connected layer. Every neuron talks to the other neuron, right? So this is like everyone doing the same part. So everyone talks to everyone. That part of it. Okay. Now we have from TensorFlow.keras.utils import to categorical. So it converts numbers like 1, 2, 3 into one hot vectors. Like 1 will be converted to like here, 1 will be converted to in this problem 0, comma 1, comma 0, like that. Okay. So this is the way it is getting converted. Now, after this, we have just taken from sklearn.dataset import Irish dataset. I guess this part of the code or importing you are familiar with because in the earlier models also we have taken this Irish dataset to showcase this stuff, right? So I guess you are like knowing with this part that is it loads the famous Irish flower dataset and make it ready for the learning part. Okay. Now we are going for train test split. So it is a part of cross validation. So we are just splitting the data set into two parts, training and the testing part. And then we have sklearn.preprocess import standard scalar. Standard scalar, as you know, it scales the numbers so that they are balanced and helps to make it understand to the model in a form that every features get equal form. Every features get equal identification. There is no biasness over there. Okay. So to make it valid, we are doing the standard scalar. Now coming down to the exact code part. So we are doing Irish equals to load underscore Irish. So that means loading the Irish dataset into the memory. So the dataset contains the flower measurement, the flower's name, all of it, right? Sepal and petal length, their width, all of this along with the flower names it is containing. So now we are doing x equals to Irish dot data. So x is by input features. X is by input features. Okay. And coming down, we have each flower has four measurements. That is sepal length, sepal width, petal width. So x is like taking this input forward with the neural part. Okay. Now we are taking Irish y equals to Irish dot target. So y is the correct answer. That is the labels. Okay. That is the target class. So values are like why it is given 1, 0, 1, 2 because my values are like this. So my values would be like 0 that is equal to Setosa. Next, we have was that is meaning of versicolor. Next, we have the two that is meaning versidica. Okay, so Y is like the answer key you can call. So Y is the label. Y is the label. Okay, hopefully you have got this part. Now going down, we have to pre-process the data. Now we have to reprocess the data. Okay, so we are doing converting the labels to one hot encoding. That is, you already know about what is one hot encoding. So we are taking y equals to two categorical y comma num classes equal to 3. Okay, why do we do this? Because neural network don't like the plain numbers. We convert the numbers into other form. Like how it is getting convert because my data are like 0, 1, 2. These are my actual values, right? But in neural network, this doesn't have any proper identification. So it will be converted with 0, 1, 0, like this. It will be converted. For this, it will be converted. Suppose with 0, 1, 0 like this, and it will be converted into 0, 0, 1 like this. It will get confirmed. Okay, so it actually helps the software understand the class accordingly. Like why we are talking about, you'll be getting to understand this because in neural networks, things are going down in a form, right? So we need to take it accordingly so that things can be taken in that way. So this actual values need to be converted into this form. So for this, we are just doing this one hot encoding and we are using num classes equals to 3. Okay. Now coming down to the train test split, that is 80% training and 20% test part we are doing. So here what we are doing, we are taking x train, x test, y train, y test equal to train underscore test underscore split. So basically what we are doing here, we are taking 90% of the data for training purpose, 20% of the data for testing purpose. Okay, so now here we have divided it into two parts. That is, let's take it the training and next we have the testing part. So for training part, we are keeping 80% of the data. So that is basically the learning part. Next we have the testing, that is the exam, that is equal to the texting, that is equal to 20% of the data. Okay, exam or testing part, you can take it. like that. Okay. So this is how my data is coming. Now here you can see we have used test size, you are using 0.2. That means we are keeping the test data 20% of the data as test data. That you can change also based on your wish. Basically, it is standard to keep it 80-20 or 70-30. Okay, now this is what you are doing. So if any case you are just keeping more of the data for testing and you are going around like keeping the small data for training, in that case your model won't be learning well. So you have to keep this thing in mind. Okay, now we are going for a random state that is equal to 42. That is same split every time we will be taking. So that's why. So it is basically for taking it in that way. Now we have stratified equals to y. That means equal flowers in trade and test. So that is equals to, we are just taking it in that way. Okay. Now we have to do the scale features. We need to scale the features. So see, feature scaling is the part. So we had using scalar equals to standard scalar. Okay. That creates a scaling machine. Now we are using x train equals to scalar dot fit underscore transform x train, because we are just doing it for the x train and x test, because we need to, because x contains all of the features like the input features like the sepal length, sepal width, but the y it contains only the target classes or the actual classes. So we need to take it into that form. That's why we are just doing the scaling on x train and x test. Okay, so it actually learns the scaling from the training data and converts the value into mean and median. Like if mean equal to 0 and standard deviation equals to 1. So we are just converting the values to mean equals to 0 and standard deviation equals to 1. So that makes the learning fair and faster. Okay. Now coming down, X test, that is we are using scalar dot transform X test. So it is use the same scaling on the test data as well. Okay. Now we are doing build the single layer perceptron model. Okay. So this is basically model equal to sequential. Okay. Model equals to sequential. That means it creates the empty neural network that is ready to add the layers. Okay, I guess you have understood, like you all know about the perceptron, a single layer perceptron, how it works. So it is just taking it in that format so that the things are easily understandable to you and you are able to get it in that format, right? So that's why we are just taking it in that way. So it actually model equal to sequential. It actually meaning like creating a empty neural network which is ready to add the layers accordingly. Okay. So model equals to add like models dot add. So we are just doing then we are putting 3 comma input underscore shape, so that is equal to 4 comma accordingly. We are just taking it and activation we are using softmax. Okay. So here why we are using del that is 3. So that is it contains 3 neurons. It contains 3 neurons, one for each flower type. Okay. Now input shape we are using 4 comma 4 comma like the blank part of it. So each flower has 4 inputs that we maintain because we have what we have sepal length, sepal width, petal length, petal width. So four inputs are there. So for input shape, we are using four. So each flower has four units. So model expects four numbers. Okay. So this is the idea. Now activation we are using as softmax. So it converts the output into probabilities. Out of 100%, we will get the probability. Okay. So this is how my probability will be showing. Suppose if I have the after softmax, my value will be coming as 0.1, comma 0. Comma 0.8, comma, we are taking 0.2. Like this, my probability will be coming. Okay, this is after softmax. Now we have to compile the model. Compile the model means we have to, what does this compile mean first? So this is the final instruction before learning. So we are using the optimizer, that is Adam, that means small weight updates and learns fast. That is why we are using Adam. And loss, we are using categorical cross entropy. Okay. So that measures how wrong the prediction is used for multi-class problem, right? This is a multi-class problem because this is not the binary one. There we have three different classification, like three classes of flowers we are having, right? So that's why we are using loss equal to categorical cross entropy. Okay, now we are using matrix, that we are using accuracy to show the correct percentage accordingly. Okay, so this is for compilation of the model. Now coming down with the training of the model. Training of the model, like we are using history equal to model dot fit. So that means we are just going like putting the values, like we are giving the value with the X trade and Y trade values for learning, and we are using epoch, that is equal to 50. That means model sees the data 50 times, like studying the same book again and again for revision, right? So we are going for 50 epochs. Batch size we are taking 5, that is learned from 5 flowers at a time. Okay, now we are taking validation underscore data. So that is why we are using that check the performance on test data during the training, and also checks the performance on the test data during the training, so that for each of the step, like each of the 50 steps, we are getting a validated score. And verbose equal to 1, that shows the progress on the screen. Like if you can see, we are getting the progress out here. We are getting the progress out here. Okay. So what is the progress? Like you are getting the epoch number, and for each of the epoch, we are getting the update. Okay, so that's why we are going for the training of the model. Now evaluate the model, evaluation of the model. So we are taking loss, comma accuracy. So which is the final result, like how good my model is doing, how good my model is performing. That is what I wanted to check. And of course, the print result neat formation and dot F 4F, that means we are getting 4 decimal places after decimal, like for loss and accuracy. So that's why we are taking it. Now coming down with the predictions. Coming down with the predictions. Why we are getting with the predictions? Because we need to see what is the predictive classes and what is my true classes. Like what is the prediction my model has given and what is the actual prediction that we want to get after the end of the 50 epochs, right? So we need to compare the prediction with the true value. So that model is doing, and also since we can do it after the end of the learning phase in the prediction, how it is moving, that we need to go. So here how we are moving, we have loaded the data, we have cleaned the data, we have built the model, then we have trained the model, we have tested the model, and then gone for prediction. Okay, so this is what we are getting here. So after learning, like after we have just run the code, you can see this is the first one, epoch 1 out of 50, because till 50 epoch we have given. So at 50, we have got the accuracy as 15%, and the loss was large, that is 2.31. The valid, like the accuracy is coming out as 13%, and the loss we are getting as 2.47. Okay, so this is the condition at the first stage, like it's epoch 1. Okay, now, initially, you can see that the values are changing. Here, you can see in epoch 3, the value has changed. Like in the epoch 2 has also the change in the loss value, but a minute value change. Right? In above 3, you can see the value has changed a bit. So it has increased. The accuracy has increased from 15%. It has gone to 19%, then 20%, 23%, 24%, 25%, 30%. Next, we have 34%. Initially, it has moved to 73, 73, 73%. That is, it is keep on like remaining the same. Till 50 epoch, we have got the accuracy at 73%. And the value loss, the loss has changed to 0.5594. And the value loss that we have got, that is 0.5750. So this is what we have got up here. Okay. Now, if you can see about the predictions of the actual, you can see this is the predicted value and these are the actual value. So among this, we have got this value like 1 and 2. This one is the misclassification that it has done. Okay. So the misclassification done by the single layer perceptron. Okay. This is how we have to go ahead for the neural network, single neural network. Okay. Now we will be going down to the multi-layer perceptron. The same data set we will be taking and seeing how it is moving accordingly. Okay. So that is what we will be doing. So here basically we will be building a multi-layer perceptron and learn from this Irish data set. And the same thing it will be doing, the classification it will be doing at the end. Okay, so now what we are doing, we are taking the multi-layer perceptron for iris data set. So here, the same way we have just taken the like all of the important important libraries. We have taken NumPy, we have taken TensorFlow, we have taken then after that we have taken TensorFlow.keras.model. All of the ones that we have taken initially, we have tried and taken it. Okay, now after this evaluation, like after this importing of the data set, we have to load the data set. Before that, what we have done, we have just fixed the random seed for reproducibility. That is np.randomSeed 42 we have taken. So this meaning that we are fixing the random numbers in NumPy so that the result stays same every time. Okay. Now we are doing tf.random set seed 42 that we are doing so that uh, fixes the randomness of the TensorFlow as well and makes the experiments reproducible. Okay, because we are going for 50 epochs, that if we are going for more epochs also, if the randomness are changing every time, so we will be that will be a problem. That's why we are fixing it. Okay. Now we are loading the Irish dataset. So we are using Irish equals to load underscore Irish so that it loads the Irish dataset into memory. Okay. Now we that contains the flower data plus answer. So that means we are just getting it along with that. Okay. So this is because of load Irish. So that will be loading the Irish dataset into the memory and will contain the details of the flowers like petal length, petal width, along with the actual answer. Now we are just going for iris.data. That means we are getting x equals to the input. Like this, x is the input feature. As you all know, up here, this should be common features that are the input. So let me write it as input features. Okay, and irish.target, that is the correct answers. Okay, now we have to split the data accordingly the same way as we have done it. So we are splitting the data into 80 and 20%. So 80% for training and we are keeping the 20% data for testing purpose. So we have xtrain, xtest, ytrain and ytest. So xtrain is basically learning the inputs and ytrain is basically learning the answers. Okay, and X is basically the inputs that we are going for the final validation, and Y test is the result for those for the input for the testing purpose. Okay, now test size we are getting as 20%, and we are taking random state 42 so that we are getting the same split always, and we have used stratified, that is y, so equal flowers in train and test that we wanted to take. Okay, now we have to convert the labels into one hot the same way as we have done it for single layer perceptron. The same steps we are taking for multi-layer perceptron. Okay, so the major difference would be coming out while just taking it forward for the neural network. Okay, after feature scaling, the same way we have done the feature scaling till this part, we have done the feature scaling like the normal way, like the way we have done it for single layer perceptron. Okay. Now coming the major part, that is building the multi-layer perceptron. As you know, in case of multi-layer perceptron, we have like more than one hidden layers, right? So here we are using model equal to sequential, so that creates a neural network that is ready to add layers. Okay. Now we are using model.add dense 16 input shape 4 activation, that is ReLU. Okay. So in the first hidden layer, so this is my first hidden layer. Here I am adding 16 neurons. Input is 4 features because my X is the input, so that contains 4 features: sepal length, sepal width, petal length, petal width. And the activation function I am using ReLU. Okay. Now here after that I am adding another hidden layer that contains 12 neurons that learns the more complex patterns. Okay, here also the activation function I am using ReLU, and then I am using another hidden layer, sorry, another hidden layer, that is the third hidden layer. It contains 8 neurons and going down for deeper thinking. And then finally we have the final output layer where we have the 3 neurons and the activation function is softmax. Now you have to just compare this part with this one, right? So here in the single layer perceptron, we have just taken the same way the model, okay, where it is, yeah, model equals to sequential. So we are just taking that we are just taking an empty neural network and we will be adding it up. So as you know, in case of single layer perceptron, only one dense layer is there, right? So we are just taking the dense equals to 3. So 3 neurons would be there containing 4 inputs and activation function softmax. There is no different hidden layers we are adding. So it is simple, like it is simple way. Like there is only one layer that we have taken it forward. Like that one layer, one dense layer is the final output layer. There is no hidden layer. Like it is one hidden layer in the sense I have told you one hidden layer. That means there is only one layer. Like if you can recall the figure of the single layer perceptron, it contains a single layer, that is two input layer going down with the like one single output layer. The formation of a single neuron is taking out for the single layer perceptron. Okay, so only one dense layer is forming up here. That is the only one layer, that is only one output layer is going for this. Okay, now coming down here, yeah. So after this is how I have taken it. Now in my output layer, I have 3 neurons, that is for 3 flower classes, and the activation function I have used softmax. Okay. Now compiling the model. The same way we are using Adam. Adam is for smart weight updation because we need to backtrack. We have to just take it forward. Like at the initial, at the first go, my model won't be predicting well, right? it need to backtrack itself and need to like adjust each of the stuff. So we are just taking atoms like that category. Then we are going for categorical cross entropy the same way, that is for loss, and for matrix we are taking accuracy. Okay. Now we need to print the model summary. So that's why we are using model summary, and we are just training the model. So the same way we have trained the model, we have used epoch 50, batch size we have taken 5, and validation data X test, Y test we have taken, and verbose 1 we have taken. Evaluation, the loss and the accuracy we have taken, and making the prediction the same way, the way that we have taken. Now coming down to make prediction, pred dot probe, that is equal to, we are taking model dot predict x test. So it gets the probability for each of the flowers, so that we are getting it like that. And then we have used pred underscore classes, that is equal to np dot argmax preb dot probe comma access equal to 1. So that means we want to choose the highest probability and convert softmax output into class number. Okay. And we are getting the true class, that is np.argmax ytest access 1. So it is converting the one hot labels back to the original number. Okay. So now we are just printing the predictive classes with the true classes. Now here you can see the values. Like here, the dense layer 10, dense layer 11, dense layer 12, dense 13. That is how it is coming. And output shape, it is coming like that. Now coming down for the first epoch, the accuracy is 65%, loss is zero point 0.9, and the validation is 0.87. And coming down here for the final layer, like the final epoch, we are going the accuracy as 99%. Okay, and the validation loss we are giving 0.0875. So the test accuracy we have got as 96% after all, and the predictive class we have got as 0211 010021. So it is exact same. There is no misclassification that has happened. So we can see with the exact values, exact same thing, just by importing the multi-layer perceptron on the same data, my model has performed better. So single layer perceptron didn't take it that well, but when we are just going down for multi-layer perceptron with the exact same data, it had worked like accordingly very well. Like there is no misclassification that we can see up here. So it has predicted each of the test value accurately. Okay, so now coming down here for this part, if we are like we will be just checking if we can just change the epoch to 150, how the things are moving. Okay, so we need to run this. Would take a bit time to run it. Just wait. So it is printing accordingly. See, the accuracy is going. Accuracy is increasing. So in my final stage, the accuracy you can see now, if I have done nothing, I have just increased the epoch size, like the how many times the model will be able to see the training data, right? That I have just increased. So you can see now the accuracy is coming up to 90% and the prediction is going absolutely correct. There is no misclassification that is happening, right? With 50 epochs, we have got the accuracy, not that much. But if we are changing the number of epoch, the value is exactly affecting. So that's why this hyperparameter tuning is a major part, because this epoch size we as a human have chose, right? So you can see, so we have now the same model, nothing I have changed, just changed the epoch size. Now it is performing exceptionally well. We have got the accuracy, test accuracy as 90%. Though for multi-layer perceptron, it has performed better. With the accuracy, we are getting here as 96%. And the last layer, that is 50 epochs, and the epochs are also less correct. So here you can see the accuracy is going 0.99. So 99% accurate it has gone. So now if I have increased this to 100 epoch, what major change we will be getting? Because that model has, like with 50 epochs only it has performed good, right? So for 100 it will be definitely performing better. So yeah. You can see here, so now it has gone up 6667. So last, this is the accuracy because it has performed the same way. Like it has, for 50 epochs only, it has given the major things correct. So there is no problem of taking it. Here we are getting the val accuracy as 0.9667, and the value loss we have get as 0.0697. So that means the it is taking it absolutely well. Okay. So there is no problem with that. Now we are taking a simple ANN for classification using IRIS dataset. So here basically we are just programming a model that is a simple artificial brain, that is ANN, simple neural network, like simple artificial neural network. The same way we are taking it and are just going with the same data set. Okay. So we imported all of the essential libraries, now just gone fixed the randomization accordingly. Now we have just loaded the data set, split the data set, now gone for standard scaling, like we have scaled it down. And also we have done the one hot encoding on the train and the test part, like the actual labels and the given labels, that part. Now coming down to the model part. Coming down to the model part. Here you can see we have taken like model equals to sequential. Now we have just gone ahead and just take it in format that we are just going ahead and like it is like creating an empty brain and starting for the learning, ready for the learning. Okay. Now the first hidden layer that I have added with the dense 8, that is, it contains 8 neurons, input size is 4 features, and we are using redo activation function. Okay. Now, again, we have just taken it forward with a dense, like the final layer, the output layer, that we have taken 3 neurons and we have taken the activation function as softmax. Okay. Now we have just compiled the model. That is, for that we have used Adam. Next, we have categorical cross entropy, and the evaluation matrix we have taken as accuracy. And we have got the model summary. Model summary, it shows the model structure and how the things are moving. Now we are just going for model history equals to model fit. So we are just training the model with this part with Y train and Y train. X train and Y train, X train and Y train, sorry, it's X train and Y train. Epochs we have taken 50, so that for 50 epochs only we can compare. For 50 epochs with single layer perceptron, there is a misclassification. We have got around 70% of accuracy. When we have changed the epoch to 150 epoch, now my accuracy has changed to 90%. Okay. For the multi-layer perceptron with 50 epochs, we have got an accuracy of 96%. Now, the same way for simple artificial neural network, we have taken the epoch as 50 and batch size as 5 only, and verbose 1 the same way. So that we can just compare at the end. So all of the things are quite same. Now we are just seeing For epoch 1, we have got the accuracy as 0.4, and initially when we have gone down, we have got the accuracy that is like final test accuracy that is coming out as 0.833. So for sample 0, prediction was 0, actual was 0, prediction was 2, actual 2, prediction 1, actual 1. So majority things are going good. But here we have got a misclassification for sample 5. Prediction was 2, but actual was 1. Okay. So there is one misclassification that we have gone for 10 samples. Okay. So this is basically for ANN, simple ANN on Irish dataset. Now we are going for means digit recognizer using fully connected ANN. So the similar way we have taken it, we have just imported all of the necessary libraries. Now we have gone down for reproducibility. So we want to fix the randomness up here. So we are just fixing the NumPy randomness, and we are fixing the uh, TensorFlow randomness. Okay. Now we are downloading the mint data. So we are just taking it down, and we are already splitting it into train and test so that we are just getting it like that. So we load the digit image. We are already splitting that into the train data and the test data. So what's inside? Inside X train, we have the pictures, and Y train, like Y train contains the pictures, and Y test contains the correct digit. What is the exact digit? So we have got the different pictures of the digit like 1, 2, 3, 4, and actually their labels, what they are. 1, is it 2, is it 3? With the picture, we are going to recognize. Okay. Now, coming down to this optional step, we want to quickly print the shape so that we know what we have. Okay. So here, if you are printing it up, so this is the printing. So this is actually the prediction part. So here basically we have predicted the exchange shape. So this is the shape. We have got 60,000 for Y train. We have got the 60,000. So since Y contains only the labels, so we have got only the 60,000. But exchange contains all of the input values. Okay. X-test contains 10,000 data for testing, and Y-test is the actual label. That is what we have taken. Now we need to pre-process the input image, convert into float, and scale the pixel value from 0 to 255. We want to pick coming down to 0 to 1. 0 to 1. Okay. That's what we want to do it up here. Okay, we want to pre-process the input image. We want to convert to float so that we are just taking it that way. So we are doing here the same way. So here basically we won't be converting the pixel value that is of 0 to 255 to 0 to 1. So smaller numbers help the brain learn better, right? So that's why we are converting with this step. Now we are taking x test equals to x text dot as type float. So this means like same scaling for the testing image also. So we are doing the scaling on both training data and also on the testing data. Now we are converting the integer label for the one hot encoding because in Y contains the label. So it contains the value as 0, 1, 2, 3, 4 like that. So that needs to be converted, else my model won't be able to understand. Okay. So convert the digit into vectors. Suppose we have the value as 7. How it is getting converted, that I am showing. Okay. So we have the digit as 7. So it is getting converted into 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Then we have got 1. Then we have got 0, 0, 0, 0, like this. Okay. So we have 1, 2, 3, 4, 5, 6, 7. Like in the first place, we have got 7, 0, then 1, then 0, 0. Okay. So that is how the digits are getting converted in case of categorical, like two categorical when I am doing my Y labels are getting converted into this. Okay. So this is how it is getting converted. Now, after that, after that, we are just building the sequential model. So we are building the neural network. So we are using starting with model equal to sequential. So here, since it is a like taking it in that way, like it is a form that we need to take this forward. So we are just taking converting the 2D image accordingly. We need to have to convert it. So that's why the first stage we are using the flattened layer. Okay, so that converts the 2D image to 1D list. Okay, so if my values are like if I have 28 cross 28, that is 784 numbers, like the flattening the photo into a long line that we are doing, like it is converting from matrix, it is converting and storing in a 1D list. Okay. Now we are just going for dot add dense. We are taking 128. So 128 neurons with ReLU activation function that we are using. So model dot add dropout, we are using zero point 0.2. That means randomly turn off 20% of the neurons and prevent overconfidence. It's like forcing the brain to practice without cheating, right? So that is what we are doing out here. Next, again, we are adding the second hidden layer up here. This is the second hidden layer. So we have used 64 neurons up here, and it learns the more detail and the integrate patterns. And we have the activation function as ReLU for the hidden layer. And finally, we have the output layer, and we have given 10th because the digits are from 0 to 9. So we have got 0 values. So that's why it has changed to 10. So we have taken 10 neurons because the digits are from 0 to 9. And we are getting the activation function as softmax. Now we are compiling the model. The same way we have taken Adam optimizer, loss we are using categorical cross entropy. Next we are using matrix as the accuracy. Right now we are printing the model size. Now we are training the model. Here we are using the X-train and Y-train, the values we are using. Epochs we are taking as 10 epochs because the data is huge. So we have to take it to 10 epochs. Now we are going for batch size. So we are going for the batch size as 128 that it will see 128 image at once. Next, we have gone for validation split. So for validation split, we have taken it for zero point 0.1. That means 10% of the data is kept for validation. Like 10% of the data we have kept it for practice. And verbose is 1. So that can be put down in the screen for output the output. Okay. Now we are evaluating the final model on the unseen test data. So that we are just going for the test loss, test accuracy, so that we are getting the values accurately. Now predicting the first 10 a test image showing the result because I need to see the result. That's why we are just doing it. So after that, we are just predicting it that way so that we will be getting the first 10 image along with the predictive value and the true value. Okay, and we are plotting the first 10 image with the predicted and the true labels. Okay, so now you can see here. So here my accuracy for the 10 epochs, we have got the accuracy that has came down as 97% accuracy we have got. So we have got the true value as 7. This is the image. So prediction is true. Prediction is 7. True is 7, and this is the image. Prediction is now for the second image. Predicted is 2, and the true image is also 2, and this is the image. Okay. So this is how we have got first 10 images. So you can see this is 5 and this is 5. So it has performed exceptionally well because the predictive value matches the true value and the image is like this. So it has actually performed well. So this is the part of CNN classification, the same way as CNN. So here we are doing the convoluted neural network on the means. So here basically we have just used the flattened and we are just for this basically we are using this fully connected ANN for this part, and now on the same data set we are using the CNN, the convoluted neural network. Okay. The same data set, the means digit data set, the same data set we are using the convoluted the CNN, that is convoluted neural network, and try to see which one is performing better. So we have just taken all of the required data set. Here you can see like till this part is same. We have from TensorFlow.keras.layers. We have just taken in all of this. So conv 2D, that is the eye that scans the image. Now pull max pulling 2D, that is actually keep the strong signal. Flatten, as you know, straightens the image as we have done for ANN, that converts the image into 1D list, 2D image to 1D list. Dense is the thinking layer, and dropout is for brain forget some of the little part of it. Okay. Now here, after that loaded the image, now we have to pre-process the data. In case of pre-processing the data, we have just like in this form, we have the first place we have taken this. This is basically CNN needs 4D data. Like that should contain the height, width, color, the channels, like the color channels, the number of image, then height, then width, then color channels. Like that it is going. So we have the data like that. So before, if my data is like, initially if we have can see my data is, okay, yeah, my data is like this, right? 60,028, comma 28. Now it will be converted to, since it is like 4D, so 60,000 comma 28 comma 28. Now it will be converted to control C, control V, control C, control V. Array, why it is not taking? Okay, just a minute. 28, this would be 28 comma 1. So it will be converted from 3D to 4D, right? This 1 actually means the grayscale image. Okay, 1 means the grayscale image. Now going down to this is the ANS. We have to check it for this. Okay, this one we had supposed to take. Okay, so we are reshaping it basically. So we are same reshaping for the test image also. So we have taken the train image and test image. So we have done the reshaping of the train image. So the same way we are doing the reshaping for the test image also. Now we have the pixel value from 0 to 255. That needs to be converted to 0 to 1. The same way as we have done it for ANN, the same way here also we have to do it for CNN. Okay. So we have done it. Now we have to convert the labels, that is one hot encoding. We have to do it. So now here convert the labels to one hot encoding for the Y train and Y test, the same way as I have shown you. So this is how it will be going. Now if it is 2, then it will be getting converted into 0, comma 0, comma 0, comma 2, or like sorry, 1, sorry, 0, comma 0, sorry, 0, 0, 1. Because it is 2, so we will be having in the third place the value should be 1. Next, it will be converted to the rest 1, 2, 3, 4, 5, 6, 7. Like this, it will be going 7, 8, 9, 10. Yeah. We have to take it like that. Okay. So now going down here, the same way we are doing it for y test, same way converting for the test level. Now here we are just building the CNN model. Okay. So CNN model. So what happening here? We have 32 filters up here, like 32 filters we are putting up here. So each filters look at this 33 cross 3 pixel, scans the whole image. Okay. What does it learn? The ages, the curves, the lines, everything it will be learning. Next, we are going for the pulling layer, max pulling layer. So it shrinks the image, keeps the stronger features intact. Okay. Now we have this again. We have this. So we are just adding more layers, like more filters. That is 64. So 64 eyes we are getting. So for more complex pattern, next we are again adding the pulling layer up here, so that again shrinks the image and keeps the important details only. So next we are adding flatten. So flatten layer that converts the 2D image to 1D. 2D image to 1D. This is up to this much we have to do. Now we will be adding the dense layer, like the fully connected layer of the neural network. There, the first activation function I am using ReLU, and then for the dense layer, the first we are taking 128 neurons. Next, we are using the dropout, that is zero point 0.5. So randomly turning off 50% of the neurons. So that actually prevents the memorizing and helps in real learning. Okay. So that's why we are doing it. And finally, for the final output layer, we are taking dense equals to 10. That is, since our digit is from 0 to 9, we have got 10 neurons, and activation function, we have used softmax. Now we have compiled the model with the optimizer loss and the matrix as same. Now we have trained the model for 5 epochs batch size. We have used 128 validation data is X test and Y test, because we are training the model on the testing data. Okay. And then finally we have evaluated and we have got the prediction with the predictive class and the true class. So here we have got here we have it just plotted. In the initial case we have plotted it, but here you can see we have plotted it, and we have the accuracy of 99%. That is better than the simple ANS that we have taken it for training this data. There is no single misclassification that has happened, so every class has been equally performed well. Then also, in case of single ANN, we have also got the validation accurately. Validation accurately means it has predicted all of the classes well, but the accuracy score was a bit lesser. I guess let's check it. Here it is 99%, but here it's 97%. Okay. Not bad though, but it is performing better in terms of accuracy. But though there is no misclassification that you can see up here. Okay. Now moving down to the neural network. So this is the neural network that we have taken it up. So this is the recurrent neural network. So recurrent neural network, that is the part that we need to take it up here. So it's like you can think about a movie review in a sentence. The sentence has the words, so word come one after the another. So recurrent neural network remembers the previous word while reading the next word. So this is basically for the memory perspective. We have imported all of the neural network. This is basically for sentiment analysis on IMDb dataset that we have taken. So the dataset contains 10,000 words. So we will be just taking it like that, more than 10,000, I guess. So we are just taking the top 10,000. So we have just imported the IMDb dataset. We have imported sequential for the layers. We have basically imported embedding, simple RNN, and dense. Now, the same way we are using we are loading the data set. So for loading the data set, we are just taking it forward. Num word equals to 10,000. So you are using like the top 10,000 most common words, ignoring the rare words that like taking it like that. Okay. Now we are using the pad sequence that makes the reviews of the same length basically. So here we are loading the movie reviews already splitted into training data and testing data. So what is inside there? So suppose I have like how we are taking it. Suppose I have the word this movie is great. This movie is great, right? So how it is storing? So it is storing suppose 14, comma 25, comma 63, comma 402. Like this, it is getting stored. Okay. So it makes the reviews of the same length. That's why we are using max length equals to 200. Max length equal to 200. Okay. So each review will have 200 words. Short reviews will go for adding the zeros and long reviews will cut the extra words. So we'll keep all of the part as same as 200. Okay. Now we are just going for making each of the training reviews exactly of 2000 200 words long, and we are just going it further. Okay. Now, suppose my data is like 200 words I have taken. Now my value is like suppose 5, comma 18, comma 90. So this is the length. So I have to take it to 200. So I'll just add 0, comma 0, comma 0, 0. Like this, I'll be adding and I'll be converting this to 5, comma 18, comma 90. Like that, I'll be converting. Okay. So this is how it will be converted. Now we are just going for X test that we are using pad sequence X test comma X length max length equals to max length. So same padding for the test reviews also I am doing. Now we are building the RNN model. So for building the RNN model, so what does this embedding part do? Because after we have just taken the empty layer, we have gone for embedding. So it converts the whole number into meaningful vectors. So we are just converting that into the meaningful vectors. Like suppose if I have the value as good, so it will be converted into 0.2, comma 0.8, comma suppose minus 0.1, comma dot. Like this, it will be converted. Okay. Now, if I have the bad value, so that will be getting converted into minus 0.7, comma 0.1, comma 0.5, comma dot. Like this, it will be getting converted. Okay, so my num was equals to 10,000. Now we have 32 here because as you remember, we have written 32 up here. So why we have used 32? So each number, each word becomes 32 numbers max. Okay, so that is what we will be doing. So 32 numbers, it will be converted. Now input length equals to max length. That is input length equals to 200. Okay, so that is what we have taken. Now model dot add a simple RNN. So it reads the review word by word, remembers the previous word. So this is a good movie. So is going like this. This is a movie. This is a great movie. Or if I am writing, this movie is not good. So not affects the meaning of good, right? So we are just taking it like that. So we are just taking it like that. And here we are using tan age. Because why we are using tan age? Because it keeps the value between -1 to 1. So that is good for memory control. That's why we are using tan age. And finally, For the output layer, we are using one one values like one neuron, and we are using the activation function as sigmoid. Now we are going for the compilation. The same way we are going for the compilation. Like if we are just for sigmoid, as you know, there are three divisions: 0.0, 0.5, and 1. 0 is like very negative. 5 is like neutral actually, and 1 means very positive. Now we have to compile the model. So the same way we have compiled the model, we have trained the model. Now for the training purpose, as you know, we have gone for X-trace and Y-test. We have got epoch, three epochs. So we'll read all reviews three times. That is what. And backside we have 64, that it reads 64 reviews together. For validation data, we have taken X test and Y test because we will be going for validating the data for X train and Y test only, and verbose equals to 1 we have taken. Now we are just evaluating the model. So now you can see the three epochs it has taken. Initially, the accuracy is 0.6. Next, it had converted to 0.5, 0.85, and accordingly, it has gone like this. Okay, now if I am just changing this to suppose 5 and now running it. Of course, it would take time, just have some patience. It will be going accordingly because it had to run for all like 10,000 data, and also about we have increased the epoch, so we will be, it is doing it. You can see it. So now the accuracy is going from 60%. Now we have the accuracy increased to 82. Now here the accuracy has increased to 88%. Here we have got the accuracy that is 92%. Now here the accuracy is going as 95%. So here my accuracy is going as 95%, but here if I am going down here, the val accuracy that is 81%. So the test accuracy is going as 0.8115, that is 81% accuracy it's showing. Now if I am trying to improve this one and making it like 10, and we have the value as 0.8115, right, with the test accuracy. Now we have to just take it and see if that is increasing or not. Okay, so for the first case it has done, it is doing actually. Yes, so it has done. So accuracy is going as 72%. Next value accuracy is moving down to 84%. Here the accuracy we are getting as 80%, 57% it has started from. Initially we have taken 81% actual, right? So we need to just see is it going like that or not. So that we need to just take it and check. So till 5 we have got as 81%, 81.84%. And here the accuracy is 82%. Now it has changed to 80% value accuracy, like it is decreased a bit. Now it is again coming up as 81.48. Now this is the ninth one. You can see 80.89, so it has decreased. Now final one, 10th epoch. We have just decreased it to 0.76, so the test accuracy has decreased from 81 to 79. So it's not always the epoch that matters. The other things also matter. So that need to be taken care accordingly. Okay. So this is how you can, this is the perfect idea of showing, like, not always the accuracy that is the main important thing that matters. So just by taking it that way also matters. So we have to just take that accordingly. Now I am just changing it to 3, and now I am just going it further. 3 epochs I have given now. Let's see. It was going for 84%. Here we have got 82%. So finally, my accuracy come down to 82% from 76 to 82. That also matters, right? So also we need to check it with the for the evaluation, we need to just check it accordingly, and we need to find it like that so that we are getting the values all way. So if we are just changing this to 1 and we want to check it, just a moment, guys, so that I just wanted to show you. Yeah, now you can see it has changed. The accuracy has changed to a 0.8466. Right? So here in this step, I have taken accuracy as 84, loss is coming out as 0.3880. So my value loss here is 84, like my accuracy is 84 and the value loss is 39. So it is doing like that because the words are like we are going with different words and it is predicting like each number of time it is performing in that way, right? So we can do a lot more with this recurrent neural networks because it somewhat remembers, somewhat it forgets, right? That is the problem with the recurrent neural network. So each time we are getting with different data and trying to find it in that way. So that is the idea. That's why we are getting the values or the test accuracy different. Okay. So this is the idea. Okay. So thank you guys. So you have, I have explained each and everything about neural network in details. You can take any other data set also for recurrent and check how the things are moving and how the things are going here, like in case of recurrent neural network. So basically, in case of recurrent neural network, it remembers the word orders, understands the context, and learns the sentiments. So ANN has no memory, but RNN has some memory. So here, in case of ANN, the order actually doesn't matter, but order matters here in case of RNN. And going down for RNN, RNN is very good with the text. So if my review text is going with numbers, like how it is going, how the flow is going, we have the review text, we are converting into numbers, the words having some meanings, RNN remembers the words and takes the final decision. Okay, so that is what we have to take it further. So this is the entire idea. Okay, guys, so you can just cross check with in your own way, just take just build a neural network with different forms or with RNN value, like with different values, and check how the things are moving, or like how it is taking. Like we have just converted the all of the numbers to the length of 32, right? So you can just check with different forms, just converting if you have any other idea of doing any pre-processing, but this is the standard word, that standard status that we need to do. That is, we have to padding the sequence. Next, we have to do for the ANN model, like RNN model, sorry, building the RNN model, then compilation. Still, from compilation to evaluation, the things are quite same as we have done it from the very beginning, right? So this is what this is. The major thing we have changed about the batch size, epoch, that is changed, right? So that is the idea. Okay. So thank you guys for connecting in today's session. Hopefully till now you have understood each and everything related to neural network. Henceforth, for the project, I guess you'll be able to perform it well and take it further. Okay. So, thank you everyone for connecting in today's session. We will be reconnecting in another session, and we will be discussing about the deployment, what deployment and the explainability in AI models that we will be discussing in detail. Okay. So, thank you guys for connecting in today's session. We will be reconnecting in the next session. Bye for today. Bye.